Alright, for question 1. The question says, how fast do you heat the sample before the solid starts to melt when determining its melting point? Check your manual very well. How fast do you heat the sample before the solid starts to melt when determining its melting point? Now, how fast do you do that? You have to do it gradually. You don't have to be fast. And the reason is what you are going to use to answer question 2. So, to answer question 1, gradual heating, slow and steady heating, slow and steady temperature is needed. And so, for you to heat your solid, your sample, and observe an accurate melting point, you have to do a gradual heating. Now, question 2. If you heat too fast, if a substance is heated too fast, what happens to its melting point? Will it be higher or lower than the true value? And this is the answer, as you can see on the screen. If a substance is heated too fast, its melting point may appear higher than its true value. So that answers your question. I'm trying to highlight for you. So I put it in color red for you to have a clearer view. If a substance is heated too fast, the melting point appears higher than its true value. Why? This is because the substance will not have enough time to fully transition from a solid to a liquid state. And this will result in 2 major problems: superheating. By superheating, we mean you are creating a metastable state for your substance, which will make it to temporarily exceed its melting point. Number 2, you are going to elevate the melting point of your substance apparently. And this will lead to increase in the melting point because you did not allow your substance sufficient time to melt fully. However, if the heating rate is slowed down, your substance will definitely exhibit its true melting point. Therefore, solid substances should be heated slowly and uniformly to ensure accurate result. Question 3. What is meant by the term melting range and what happens at this range? If you go back to my explanation of melting point, I think you should be able to relate with this melting range. The melting range is a temperature span in which a substance transitions from a solid to a liquid state. So what happens at this range? 1. The solid and liquid phase coexist in equilibrium. 2. The substance absorbs heat without a temperature change. 3. The melting range will vary depending on the substance purity. If a substance is pure, the melting range will be narrower, it will be closer. There will be not too much gap between when the first crystal starts to melt and when the final crystal starts to melt because the substance is pure. But with an impure substance, you are going to have a wider melting range. Okay, most mixtures and amorphous solids melt over a range of temperature. Okay, question 4. Why should a new capillary tube be used with a sample of compound when doing a second melting point determination? Why must you always take another capillary tube for every determination? This is simple. It is because 1, you need to have uniform heating. Using a new capillary tube ensures uniform heating, and this is because the previous tube may have undergone some physical change during the first heating process, and that will affect its thermal conductivity. You have to avoid this, so you need a new capillary tube. Number two, to avoid contamination. A new tool will prevent any residual compound from the first from affecting the second test result. Number three, for clear observation. With the use of a clean capillary tube, it will allow you to easily observe the melting behavior of your sample. Number four, compatibility. New capillary tubes are designed to be compatible with standard melting point apertures, making them convenient for laboratory use. Okay, now the last part there is the small sample size. The small diameter of your capillary tube allows for the use of a minimal amount of sample, which is advantageous when working with limited quantity of substances. So, for you to have a clean and a true picture of the melting point of your substance, you have to take note of all that has been mentioned. Use of a new capillary tube, heating gradually at a slow and steady temperature, determining your melting range, and so on and so forth. Number five, state the reason for constant stirring of the oil bits during melting point determination. One, it will allow you to have even heating throughout the oil bits. It won't be that one part is too hot, the other part is warm. It will allow for even heating, same temperature throughout the oil bed. Number two, it will prevent the formation of hot spots, which could lead to inconsistent results. Because if you don't actually stir your oil bed, some parts will be very, very hot, or some parts will be cold. It's still the same thing like even heating, so it prevents the formation of hot spots. Number three, it ensures that the temperature reading on your thermometer is an accurate representation of the temperature of the oil bed, which is invariably the temperature of your sample. Okay, now lastly, it facilitates heat transfer between the oil bed and the sample. Last question on the manual says, what is the melting point of the substance you heated? Now, this cannot be shown on the screen because it is actually what you carry out. The answer for student A may be different from the answer from student B. It is expected because the temperature you measure may be different from the temperature I measure as student B, and it will be different from the temperature student C measure in another laboratory. A lot of factors affect the temperature at that particular time, but notwithstanding, there is a range that should guide you. So for the just concluded practical for this semester, the substance you were given was naphthalene, and the acceptable melting point or the melting range is 79 to 81 degrees Celsius. So your melting point could either be 79, it could be 80, it could be 81. That is your melting point. The range is the temperature from the first disappearance of the crystal to the last disappearance of the last crystal. So that brings us to the end of experiment 1. Next experiment we shall be looking at is experiment 2, which is determination of the boiling point. God bless you all.